Welcome to Techstination. Joining us is Dr. John Smith, IBM Fellow and Manager of AI Tech at IBM Research. Thank you for being with us.
Good morning, Fred. How are you?
Terrific. Well, IBM Research today is taking a look back at some of the work done this year at its dozen labs around the world on AI. First, perhaps a little perspective about artificial intelligence. For many, or maybe even most of us, what we know is what we see in the movies, maybe see or read on the news. And some of the movies, some of the news reports can be pretty scary. I'm sure you run into those perceptions all the time.
Right, Fred. Well, it definitely is an exciting time in the field of artificial intelligence. Just a little historical perspective. Work in artificial intelligence actually goes back many decades. So it's an area that has received long study. But in recent years, some of the results that the technology field is getting are truly remarkable. But we kind of think of AI today as really two bookends. On one side, there is what you're alluding to, artificial general intelligence, maybe still in the far-off future where computers are maybe more capable than people and all of the implications of that. But at the same time, there's another bookend, which is really where we've been operating in, and we call that narrow AI. And that's where we're seeing the most success recently. And what I mean by narrow AI is, well, if we have a very well-defined problem, for example, recognizing images of cats, and we have lots and lots of data, examples of images of cats, we can teach the computer to basically perform recognition which is accurate. So that's very exciting for people because we're getting accuracies on tasks like that we've never had before. But what we realized between these bookends, there's a lot of important work to do, and particularly when we look at applying AI for enterprise domains or different industries, the tasks that we have to solve, they don't look like narrow AI. We don't have millions of examples of data to train from. So it's really this, what we're calling broad AI, this area between these two bookends where we're putting a lot of focus.
Really interesting. Now, at IBM Research, you're doing some amazing things. One of those things is called Project Debater. Tell us about that.
Yeah, sure. So Project Debater, it's part of one of our pillars that we call Advancing AI, and it's about really taking some of the capabilities to the next level, being able to do more sophisticated work and so on. Project Debater is really fascinating. It's about training the computer to be able to participate in a debate. I mean, the same way we as people may debate each other on different topics, we can give the computer a topic. It could be a controversial topic. And then we say, okay, go do your homework, research the topic, come back with arguments. It could be pro, it could be con of that topic with evidence, and put that together in a way that the computer could debate against a human, a person on this topic.
Hearing what I would say and being able to respond and essentially
Right.
tear my argument apart.
Right. So not only does the computer here and Project Debater need to go and do the research and come up with a base set of arguments, it needs to listen to what the opponent is saying, and then rebut. So there is a listening comprehension aspect of this as well, which is very important, and of course, very challenging. The computer needs to understand the speech. It needs to parse the language coming from the other person, and then it needs to put together some responses to that.
Wow. You've also been developing ways to help machines accurately recognize new objects more easily, and I think you were alluding to that a couple minutes ago. Explain that to us a bit.
Right. So again, in this journey towards broadening AI. The nature of the problems doesn't fit that one I described, where we have tasks with lots and lots of training data. In reality, we may have very little training data for something new we want to learn. It could be something like visual inspection in manufacturing, looking for defects. Maybe these are metal parts that are being manufactured, and maybe we have one or two or a few examples of the defects that we're trying to learn and have the computer be able to recognize. So there's a lot of need to be able to learn from less training data like this. And one of the techniques that we invented this year addresses this problem that we call few-shot or one-shot learning, where we can learn from as little as one example. And there's a pretty sophisticated algorithm that we've developed that will build up a model of the overall feature space that the computer can use, and it learns to generalize very well, even given as little as one example, what the cloud of samples could be around that one given example. So in effect, it trains itself based on this cloud of examples that it's been able to synthesize.
So to contrast that, the more traditional approach here, if there is such a thing with AI, would be to have millions, for instance, of images that the machine would be looking at to be able to train, to be able to recognize something else. And you're now able to, or what you're working on is a way to be able to do that with just a few.
That's right. I mean, that's the contrast between narrow AI, where we rely on lots and lots of training data, to this broader AI, where we don't think we will have that training data, that amount of training data to learn what we need to.
And you're also finding ways to not only improve accuracy, but to do it faster. And speed can be important depending on the application, I suppose.
Right. So that brings us to another one of our themes here that we call scaling AI, which is about making these AI systems faster, more efficient, less power hungry. These are quite important as the workloads get bigger, as we have to do more tasks and so on. And we had one breakthrough work which we published just last week at a conference called NeurIPS, which is one of the top AI conferences, and it's something we call 8-bit precision training. And the way to think about this one is, I guess we're all familiar with using laptop computers or desktop computers. There's a CPU in that computer, which is really the brains of the computer, doing all of the operations. And that CPU might use something like a 64-bit or 32-bit architecture. Basically, it's the amount of computer representation that it gives for performing all the math and so on. That's what can allow computers to be very accurate when they do computation, because they use such a powerful many-bit representation. Well, we were able to get that representation down to only 8 bits, which really can only represent 256 different values, and perform all of the math for training a neural net using just 8 bits, which is really quite remarkable. And we were able to do this. It required a number of inventions to make happen, and train these AI models with the same accuracy as if we had a much higher bit representation.
And what does that mean? Does that mean that this technology becomes a lot more affordable or easily put in different kinds of devices?
Yeah, it will mean potentially a few things here. I think for one, the training time is much faster. Getting down to 8 bits makes it 2 to 4 times faster than 16-bit training, and even 16-bit, is a big reduction. It also gives the possibility that more of this training could be pushed to the edge. So today, a lot of our phones are having AI capabilities. For example, they can even tag photos and do things like that. But there's not a lot of learning that happens on your phone. By getting 8-bit training, and potentially there's more to come, it gives more possibility that the devices themselves could be doing a lot more learning.
Meaning that your phone would learn more about what it sees and be able to recognize, essentially think on its own?
It could, if we correlate learning with thinking here, right? Essentially, AI models could be more customized, more personalized, and so on.
What are some of the most important areas where this technology, artificial intelligence, is being used today? I know it's all over, but what do you think is most important?
Oh, I think there are a lot of industries and applications where AI can have big impact. We have been working on many different areas that span the range of healthcare to retail to other industries. To give an example of a kind of capability that we've worked on, we have a product called Watson Assistant, which is a conversational agent. It has remarkable abilities to help automate help desks, provide assistance, maybe take on tasks that or provide assistance to human agents to help bring more automation. They can use speech recognition, speech synthesis in their operation. So really quite powerful.
Absolutely, and I mean, a lot of us have seen some of the wow applications where AI is writing songs or painting things like that.
Yeah, that's right. We did a project just in this last month around using AI to create a completely original piece of artwork. We did this for a New York Times issue on a special section on AI that was published in November. But the remarkable thing was that we tasked the computer to essentially go do the research. In other words, pick a topic, and we did that by feeding it thousands of articles from the New York Times. It was able to pick a topic. Then we said, okay, pick an illustration that represents the topic, and again, it built models. It went and evaluated images, and the task here was to come up with some original artwork that illustrates AI. I mean, we thought of this as an AI self-portrait, so it actually came up with a figure of a human hand shaking a robotic hand as the basic visual concept that it wanted to convey. But it had to create an original illustration of that, not just use a known figure. And we were able to train the computer in such a way, giving it examples of human hands and robotic hands and hands shaking and so on. It was able to generalize that and then start producing its own original content like that, which was pretty remarkable. And then we were able to do one more step here, which was to have a style of illustration. In this case, we chose the prior cover art that New York Times uses as sort of a visual style or language that the computer was able to then also model and apply to this original illustration. So even for creative tasks like this, it's remarkable. AI is having really a powerful role, and I think there's a lot more to come like this.
Boy, I'm sure. And you are looking ahead to the coming year, maybe even beyond. What are some of the things we can anticipate or look for in AI?
I think one very important direction is something we call trusting AI, and the reason this one is so important is because as we move from narrow AI to really broad applications and really progress AI towards industry problems, there are important questions that we have to be able to answer about trusting our AI systems. So, for example, are they fair? Have we taught them what was intended for them to learn? Have they learned it correctly? There are ways in which bias can enter into our learning, and that's the good thing about AI is that it learns whatever you teach it. But that's also the bad thing; it learns whatever you teach it. It means you have to be very thoughtful about how exactly you're teaching it to ensure fairness in the end. Explainability is also important. These AI systems are often used for decision support, so that means they need to be able to explain how they arrived at their decisions. Otherwise, you don't have that trust between the person who's relying on their outputs and the AI system.
In one application, autonomous vehicles, there are some who have argued that until the computer in the car is really equal to human thinking, these vehicles shouldn't truly be driverless. Any thoughts about that perspective?
Well, I would say that it's important that as we work on these AI systems, that they are fair and they are accurate, and the two really go hand in hand. It's especially for something like self-driving cars. It's very clear that that they need to be accurate for what they're doing. But if we think also about the environment in which they operate, there are so many conditions, so many traffic conditions, weather conditions, types of roads, types of scenarios that they will be in when they operate. And we have to make sure that as they're being trained, the training is balanced. So we don't get into situations where a vehicle has learned to operate very well in a city environment, but you take it out of the city and you put it in the country, then all of a sudden it doesn't work.
Interesting. So many factors to consider there, and I know IBM is working in this space too. I think one of the companies you work with is Local Motors, which makes a vehicle called Ollie.
Yes, that is some work that we have done, and I think it brings us back to really about this whole trusting AI pillar. There are a lot of challenges, a lot of questions there to basically ensure that the AI in these systems isn't biased, is explainable, and also robust. I think the way we were describing.
Well, we know about the ability to beat humans at chess and Go and things like that. How close are we to having machines truly with human level intelligence, do you think?
Yeah, so that was the far bookend that I referred to at the beginning. It's still some time off. It's hard to predict when we will get there, or even how we will get there. A lot of progress still needs to be made before we get to artificial general intelligence. We often think of it as it's an endpoint, maybe in some ways, a guiding light that pulls through some of our research. But it's still something that's in the far, far future. We're much more focused on getting from this really impressive but narrow AI capabilities that we have today to making them work for in practice for real important enterprise challenges and in different industries.
Well, there's a lot more for us to learn and talk about, and we hope to be speaking with you again. Dr. John Smith, Manager of AI Tech at IBM Research, thank you so much for taking the time with us.
Great. Thank you very much, Fred.
Now this. How many companies out there have continued to innovate when it comes to building a better radio? I'm Fred Fishkin, host of Techstination, and I'm here to tell you about the new CC Skywave SSB radio from the wonderful people at C. Crane. Bob and his crew really love radio, and it shows in this new compact model that is packed with features. Beyond great AM and FM reception and sound, you can tune into shortwave signals from around the world, listen to ham radio operators, aviation, and more. It's the radio you'll turn to every day, and in emergencies. It will run for nearly 3 days on just 2 AA batteries. Pair the sleep timer with the new Soft Speaker 3, and you've got the perfect radio for your nightstand. Of course, it can wake you up too. Click on Crane at Techstination.com and put in the code Techstination for a free flashlight with your order. They love radio, and you'll love Crane.